this experiment you will be shown how to determine the partition coefficient of drugs. Okay. So, what happens to the drug when it gets consumed? You see that in order for the drug to bind to the particular portion of activity, the body of activity. Okay. So, you have so many things here: kidneys, bladder, bile duct, liver, and of course, if you want to have a reach the brain, you have a blood-brain barrier. Okay. So, an oral drug, whatever we are talking about is mostly is for the oral drug. The oral drug must be able to dissolve in a physiological conditions, and of course, because if it is going through the stomach and intestine and etc. and pancreas, all the things, it has to survive the pH range between 1.5 to 8 pH, and of course, it has to does not get destroyed by the intestinal bacteria present in our entire gut bacteria is present, and it is able to cross the membranes both in terms of cell membranes as well as into the bloodstream, then to the point of action and everywhere, and avoid active transport to the bile, because if they go to the bile means it will go to the kidney, it will get extracted, and to avoid the excretion by kidneys and partition into target organ. Basically, if your target organ is the liver, it is be able to do it, and avoid partition into the undesired places like brain or fetus. So, you should not, even for a pregnant woman. So, if it is unnecessarily getting into the uterus and go to the fetus, it is the complication may arise. So, when the drug, you can find out that the drug must be able to have so many things to be satisfying it actually, and in that we are trying to find out the only one small thing, and that is the reason, and the physical properties for the small molecules is very important things. Before the drug reaches the intended site, there are many hurdles to overcome by this one, and many of them people are trying to model now, okay, using a simple physical chemistry models or properties, and people are trying to find out the how we can do the lead optimization and lead identification, how do we take it forward to the program forward. Okay. And this one, we are not talking about legal or anything, inhalation or anything. So, we are talking about only one thing here, we are talking about how to find out the log P value. Okay. So, log P value, that is the only thing we wanted to find out for a drug. So, what is the log P value or log P of a compound? So, and also the pH also varies quite a bit between this one. How this pH is also going to affect the intake of the drugs. If you have a aqueous humor is about pH is about in the blood is about 7.4, colon is about 5 to 8, when you are fasting is about 4.4 to 6.6, when you are fed 5.2 to 6.2, and stomach when it is fasting 1.4 to 2.1. So, the drug has to go through, oral drug has to go through all these pHs in order to get the ionized form of the drug which diffuses into the bloodstream actually. Okay. So, for that reason you should know a little bit more on the lipophilicity and how the fat liking and etc. Okay. So, lipophilicity is one of the important physical property of a drug in relation to the its absorption, distribution, potency and elimination, that is one. And it is important all the following because of solubility, absorption, how it is going to bind to the plasma of protein, and the metabolic clearance and volume of distribution, enzyme and receptor binding and renal clearance, how it is going to increase the CNS penetration, central nervous system, and whether it is going to stored in the tissues or not, and the bioavailability and toxicity, all of them kind of dictated by the lipophilicity. The drug and also the hydrophobic effect. So, hydrophobic effect, why basically the molecular interaction, why water and oil do not mix. So, because you can see here is a benzene ring, it is a water surrounded by that, there is nothing to what do you call to the hydrogen bonding between the water molecule. When you are having a water molecules, they do the hydrogen bonding, they get separated like this and benzene separate like this. So, if there is a way to have a hydrogen bonding between these one, then you can improve the solubilization. Okay. So, this is a one simple molecular interaction to show that why oil and water do not mix. That molecules are encouraged dissociated in water, that is the one reason, and placing a non-polar surface, the water disturbs the network of water-water hydrogen bonds, that causes the reorientation of the networks, and this water molecule non-surface consequently exhibit a much greater ordering, hence the power entropy than the bulk water actually. This is for the this one. And hydrophobic, whether the molecule is too lipophilic and or is too hydrophilic. If it is a too lipophilic, that will be insoluble in aqueous media, whether it is a gastrointestinal blood or not. So, bind too strongly to the plasma proteins, and therefore, the free blood concentration will be too low to produce its desired effect, and distributed to the lipid bilayers and unable to reach the inside of the cell. So, if the molecule, if it is too lipophilic, or it may enter into the cell, but it may not get distributed where it wants, and also it will not be insoluble in the aqueous media. So, you will not be able to go inside the blood, because blood will get excreted out very easily, and because of too lipophilic, it will join too strongly to the plasma protein. So, whenever you want to make a drug, there has to be a balance between the lipophilicity and hydrophilicity. Okay. And when this compound is too polar, it may not be observed through the gut wall due to the lack of membrane solubility. Okay. So, it is important to measure the lipophilicity of a potential drug molecule, that is correct. How do we measure this? So, that we measure it by partition coefficients. So, you try to solubilize the molecule which is aqueous solution and the octanol. We use octanol, basically mimics the entire cell membrane. So, we use the octanol and water, and P is a measure of relative affinity of a molecule for the lipid and the aqueous phases in absence of ionization. Okay. This is how the P is being found, and partition coefficient usually expressed in log 10 logarithm scale, log P, is defined as concentration of P in octanol and divided by concentration of X in the aqueous solution. That is the P, partition coefficient. And octanol is the most frequently used lipid phase for pathology research. This is because it has polar and non-polar regions, because it has hydroxyl like similar to the phospholipid, and POW, that is basically organic and water, that is what octanol and water is fairly easy to measure. PO often correlates with many biological properties. It can be predicted accurately using computational models nowadays. And log P is for the molecule, can be calculated from a fragmental atom based term various corrections, and this computational way of doing it, and with the all the corrections and everything, for the beta known, you will be able to find out the C log P about 3.1. So, you will be able to find out through computation also, but we would like to do the experimentally. Okay. Why do you want to do that? Why do you want to find out the log P value? Okay. In log P value, it is one important parameter in the Lipinski rule. So, what is the Lipinski rule of 5? Although it is the Lipinski rule of 5, it is a rule of 5 only. So, most of the oral bioavailable drugs, so they have nearly about 90% of them have the following properties. Most of them have a molecular weight of less than 500, their log P is less than 5, they have less than 5 hydrogen bond donors like sum of NH and OH atoms, and then less than 10 hydrogen bond acceptors, sum of nitrogen, oxygen, and as well as the fluorine. Okay. In addition to that, a rule was proposed by Weber, that is less than 10 rotatable bonds, that is the reason addition was there. So, because of it has the multiples of 5, so this is called the Lipinski rule of 5. So, if the log P of is less than 5, the molecule is most probably accepted by the medicinal chemist, so it will get inside the system. Okay. So, otherwise the absorption and bioavailability are likely to be poor, and this is mainly for the oral drugs only. So, why do we have to have the lipophilicity and hydrophilicity for that? Because you have a lipid bilayer here, this is the aqueous environment outside. The drug has to be reasonably soluble inside the aqueous environment, and it has to penetrate the cell membrane, and it has to go the hydrophilic environment again, and again it has to go out, even if you are going via the intestine and getting into the bloodstream. So, all the things has to go via this various cell types, and it has to go to the passive diffusion between the hydrophilic, which is the aqueous environment outside, then hydrophobic environment, okay, then hydrophilic environment, it has to go out again to the this thing. So, in other words, it has to be in a hydrophilic environment, it has to be reasonably soluble, and whenever it sees, it is able to penetrate through the cell membrane, and whenever it is able to find its partner or the target, it is able to go out of its more aqueous phase environment to the hydrophobic environment, that is a protein. So, to get bind to the receptor. So, it has to have a right balance of hydrophilic and hydrophobic forces within the small molecule to make the drug has a log P of less than 5. Okay. So, if log P is 1 means it is mostly water soluble, that means it has less lipophilicity, and log P is about 5 means it has more lipophilicity. Okay. The drugs in this one, what we are trying to use it, we are trying to use the sulfonamide, phenacetin, acetaminophen and caffeine. The drugs are used for the finding out the log P values, and the Kp dissociation constant will be organic divided by the water, that is your formula. And how do you find out for the through the extraction, and you will go through the reference, you will for the this one is basically again Journal of Chemical Education, okay, and Journal of Chemical Education, that is the reference, and the year is 2014, the volume number is 91, the page number is 915. Please go through the supporting information of this entire article on this supporting information. It tells very elaborate experimental procedure, how to make the saturated octanol and water saturated with octanol and everything. It has done through the very nicely. Okay. And how do we determine through the extraction? So, 10 ml of the drug stock solution was taken into the pre-saturated octanol in a separating funnel. So, measure both volumes to the nearest 0.1 ml, that is what you need to be doing, and swirl the mixture vigorously for 5 minutes, and of course, you need to shake the separating funnel, vent it, then again do that, and then we will obtain a and also if you take too much, it may result in the emulsion that may require the what do you call hours to separate. So, that is another disorder. Do not shake it too much actually. Okay. Mean you want to swirl with a vigor, not exactly to shake like this. you have to swirl with the vigor. Okay. And after 2 minutes the layer will get separated. And how do we find out the fixed laser anthem to a full spectrum scan? Because you know what is the lambda max values of these compounds, and repeat the extraction 2 more times to find out how much amount of things been solubilized in the aqueous phase and the organic phase, and you will conduct 5 extraction in total. In the absence of higher than 1, you will have to dilute your aqueous layer actually. Okay. So, when you are having the water to be extracted in water, so by the water to be extraction equal to moles now in the octanol phase. So, moles in octanol phase and how much amount of drug in octanol and how much amount of drug will be in the water extraction, that you will come to know by this one, this solution. So, if you are taking the entire extract and you are going to do UV absorption should be ideally should be 0.3 to 0.6 value, 0.3 to. If it is says about 1.5, this is not accepted. Okay. So, this is not good, concentration is too high. So, you need to dilute. So, you dilute the serial dilation you do and with the pre-saturated water. Now, you find out what is the absorptions, it is about 0.45, and now you can find out the original aqueous concentration in the phase 2. Okay. With that, you will be seeing the next video how the people are measuring the entire log P values, and it will tell exactly what the value was obtained by the TAs actually. And let me stop my introduction, and followed by the video will be played for you, or the experiment is done by the TAs.
Freshly prepare 250 milliliters of pre-saturated octanol in water. Prepare a stock solution consisting of 5 milligrams drug dissolved in 100 milliliters of pre-saturated water. Add 10 milliliters of the drug stock solution to 10 milliliters of pre-saturated octanol in a separating funnel. Shake the separating funnel for 5 minutes with frequent venting. Let the layers separate for 2 minutes. Determine the lambda max of drug using stock solution in the UV-Vis spectrometer by scanning from 220 to 400 nanometers at a 1 nanometer interval. Determine the absorbance of the aqueous layer at lambda max determined previously. Presaturated water is used as blank. Repeat the extraction twice using different amounts of the stock solution and presaturated octanol. Calculate the partition coefficient from the observed value.